Okay, so we're gonna make a component for a resistor and I think some like power chip that I picked. So when you search on JLC, right, the best place to start is like the basic parts list. Because all of these parts, I think I've said this a million times, you don't need to pay a fee to, not a fee, like an extended parts fee, so you just pay the part price. So I'm just gonna pick a resistor. I think I put it in chat somewhere. Yeah, this thing. And then when you click on it, you get a bunch of parameters about what it is. So so you go over to make your component. So you go new component and then resistors, or pick your category correctly. Like, you've got capacitors. There's some stuff under integrated circuits. But anyway, for our example, I'm just going to pick resistor, and then it will put you into a new GUI that allows you to make a symbol, footprint, and the parameters. So the whole point of this is that when you place a component in your schematic, right, it's automatically linked to the footprint, so you don't need to do it separately in the PCB. So it just keeps everything encapsulated and stuff. And you can do simulations too, that's but we don't normally do those. Normally we put them in an outside program. But anyway, once you've got this GUI up, you just put your component into the name field, and you can also click the three dots, and you get like a more comprehensive search. So you can also try this as well if it's not appearing in the drop down of the name field. And then yeah, you can say I want this. Make sure you've got the right component because your part number might conflict with another part. But in this case, yeah, this is what we want. The the resistor, and then yeah, you just allow it to automatically pull all of the parameters from the cloud, from their database and data sheets and whatnot, pricing information. Yeah, so that's the whole point of putting the name in and then going through that rigmarole. But you can see for some of these components, like this is like most of the JLC components or the LCSC components, they might have like incomplete information. If you pick up a part from DigiKey or Mouser, most of the time the information is going to be complete. But you can see this one's a little bit barren. So you can just copy in the description from JLC and and for resistors and capacitors and stuff like that, and crystals, stuff like that, inductors, make sure you use the value parameter. Just make sure that when you like put the symbol down, sorry, it shows the value. So that's where this number comes from the value parameter. So that's value with a capital V at the start. And another parameter that's also good to use is the JLC underscore PN parameter. So if you're like picking stuff off the JLC catalog and you want it automatically placed, in which case, yeah, you want it, right? You want if you're picking off JLC, you're gonna want to have it placed in most cases. So in that case, you just copy this part number. So it starts with C, and you put it in the JLC PN underscore PN field, and that'll just make it easier for when you do assembly. Okay, so in this case, I've made a resistor, right? So resistors, capacitors, they all have the same symbol. Like, you're not making a custom symbol every time you make a resistor. Um, so yeah, you just go symbol, click the drop down, and then you click existing, and then you go to components, hashtag models, and then symbols, and underneath that there's the standard symbols library. So I recommend before you start making components, just have a look through what we have here. So yeah, there's your resistor right away, but you also have other standard symbols like, I don't know, buzzer, switches, battery, crystal, ferrite core inductor. Yeah, so there's like tons of stuff here, jumpers. So have a look through it and try to use these symbols so we're not making duplicates, basically. So if you're making stuff that's like resistors and stuff, yeah, just look through this library. So pick the symbol, press OK. And again, most resistors, they're like the same package, right? They look the same. So again, you go components, models, but footprints this time, and then standard footprints. Now you could use the V2 symbols, but in my opinion, they look a bit weird. Um, so yeah, just stick with the V1, with the V1 symbols. And the the symbol you'll use is or not symbol, what am I saying? The footprint you'll use is dependent on this package value, right? So in this case, I got an 0402 package, and okay, you might look at these and say, where's the 0402, right? But actually, these are all metric codes. So these are metric, but JLC gives them, and most people will give them as imperial codes. So you got 0402, 0603, what is it? 0805, stuff like that, right? Those are all in imperial, but all of these numbers are in metric. But you can look it up online, like, and eventually you'll just remember, like, oh, 1005, that's 0402, and then 1608, that's 0603, 2012, that's 0805, and then so on, right? But if you forget, you can just look it up online for the what's it called, the metric code. But anyway, this is an 0402 capacitor. Um, I mean not capacitor, resistor or metric is 1005. So you just click OK. Yep, and you can see it there. You can like move it around and whatnot, and that's pretty much it. You just yeah make sure your folder is correct, and then you just close it, and then make sure save to server is checked, and then just press save. We use Git for our version control, so you can write a message like initial commit, but oh, I can't spell. But you honestly don't need to. Like most people here are electronics engineers, and they don't really care about the Git stuff, right? But anyway, and then now when you go into your components search, if I search at 470K, the value that I put in, you can see I've got the component here right in the search. So it's all ready to use, and you can just start placing it down. So that technique is like for basic components, stuff that has the same symbol, the same footprint. So that'll be for most of your passives, like your capacitors and your small inductors and stuff, crystals. So that's the standard for that. Now I'm going to show you another technique, which is for specialized components that have custom symbols. So what's our component? I think it's like this guy. Uh, Let me just bring it up real quick. Uh, yeah, this one. Um, Oops. So yeah, this is just a step-down converter. So the first thing you do is you download the data sheet and you go to the symbols, the pin configuration. Yeah, that's what it is. So for this component, we're going to need to make our own symbol and footprint. So what was this? This was a step-down converter, right? So for step-down converters, you can go to integrated circuits and then power supply. So this is where most of your ICs will go, like integrated circuits and then the relevant subcategory. So I'm just going to go to power supply. Okay. And then I'm going to paste in the component. And as you can see, there's like multiple that appear. If you want to be precise, you can again click on the three dots, and then pick the right component, but I think this will be fine. Okay, now you can see there's like a bunch of red parameters, but honestly, I don't care for the rule checking, so I reckon just tick everything, even though it's like it goes against the rule checking. I don't know when they added this, but I really don't care for it, so yeah, just add every parameter in and then give it a second. Yep. And then yeah, rate the first component 5 stars. That just makes it so that when you do the bill of materials, you don't get like errors and stuff. And if you want, you can actually add in the other components, not components, sorry, the other variants. So, there's this one with a dash P for some reason. Um, you can add that in, but only add it in if it's like very similar, right? Like some of them they have dash A or something for automotive variants, which are more expensive, but I mean, if the part is out of stock, you might have to resort to it. So you could add it in with 4 stars, for example. So that's one option you can do, but I'm not going to add that in because that component, I'll just bring it up again. That component seems, well, not component, that option you can see from the red box up here. There's no providers anyway, so there's like no reason to add it in. So no suppliers. Um, but yeah. So now here's the different part, right? So before we went to existing, but now we're just going to click on wizard, and now you get this new GUI that lets you basically create your own symbol, right? So you can do your symbol in a bunch of different ways. Like I don't know, you can make a quad package or something, and you can give it 32 pins, and it'll like make it for you. But I'm gonna be real with you guys. I think you should always just do dual inline package, even if it physically looks like a quad package or looks different. Just do dual inline because the whole point of a schematic is to look readable, right? It doesn't matter if it doesn't match with reality. So just do dual inline. It'll make your life so much easier to route the wires in a neat way that looks good on your schematic and that's like readable compared to like doing it physically. Anyway, right aside, yeah, put in the right number of pins. So we've got an 8-pin package. And then the next thing you want to do is just put in all of these parameters, put in all of these names. So, okay, let's just do it anti-clockwise. So, and you can see from the numbering, yeah, it'll be anti-clockwise, right? From 1 to whatever. And then no connect on 2 and 3. And then vsense on 4. Enable. Yeah, for bigger packages, it gets annoying, right? You can see this being quite tedious if you have like a huge package with tons of pins. In which case, you could actually use like VS Code and like copy the PDF and then manipulate it so you can paste it. So you can use special paste. Oh, and this package actually has another pin. I don't know if they have a symbol or not a symbol, a physical diagram of it, but okay, not from below, but you can see on this physical diagram they've got this like um, it's called thermal pad. So this is like a switching converter, so it could get pretty hot, like doing all its switching work. So that's what they call a power pad. That's what TI calls it, but it's basically a thermal pad. It just helps dissipate away heat. So, and you can even see, yeah, ground pin must be connected to the pad for proper operation. So what you can do is you can just add a ninth pad in, add a ninth one, and just call it thermal, well not thermal, call it pad. And then yeah, and then the next part is to make sure it has the right description, right? So normally in your data sheet you've got this IO column, so you can just copy that in. So put the electrical type to the right ones here. So yeah, you've got a couple of options like input, IO, output, open collector and open emitter. You could use those, but honestly I don't really bother. And you've got passive and power. Yeah, so normally I use input, IO, output, passive, and power in my symbols. Okay, so let's try this out. So we've got boot, that's an output. Output, no connects, those are just, you can just put them to passive. Oops. Passive. vsense and enable are inputs. So you can just skip over those. Ground is going to be power. So power. Vin, that's probably power. Oops. Yep, that one's input. And then this one you can just put as passive. Yep. And then you click OK. And then you are brought into the symbol editor. Okay, so again, there's like two schools of thoughts with how to make symbols. You can make them represent what they look like in reality, like what the package looks like. Or in my opinion, the better way is to lay it out in a way that's readable. So that's what I'm going to do, right? So I'm going to put my grounds below. I'm going to put related pins next to each other. So you remember um, pad needed to be connected to ground. So you might as well put them next to each other so it's easier to work with. Um, Another thing I do is I put V in above ground so that when you put capacitors, it's just easy. Like you just put them all over this side. So that's another thing you can do. Um, what's the boot pin for? Boot is output, right? So again, you'll probably look at the Hey, how's it going? Space? What's for? What's this for? Oh, probably not. You can get a chair from outside. Yeah. But yeah, if you want inspiration on how to make things look right, you can you can look at the application note on each schematic and just rip it off, right? So so again, boot's connected to the PH pin, so you might as well put them next to each other. Um, oh yeah, and with these symbols you can, where is it? Oh wait, that's an output. Yeah. So you might as well put them next to each other. The vsense pin, that's below the boot pin, and the ENA pin. Yeah, so just laid out in a way that looks nice. They'll look nice to lay out when you do your schematic. So put a bit of thought into that before you finalize your symbol. And then the last thing you do is you put a designator. So this is what appears when you've got the schematic, right? So you can see everything has a designator like C5 or U2, right? And if you go on Wikipedia, there's like a whole list of what each letter means. So you've got R for resistor, C for capacitor. In my case, I'm just going to use U for integrated circuit. So I'm just showing them how to make components. This is a what's it called? A step down converter. But yeah. So so you put your letters in, right? You can actually put any string you want in here, right? You can put any string, and you can put question marks to indicate where the number gets replaced. So I can put like U and then question mark, and then when I place it down, it gets converted to the proper number, so it becomes like U5 or something, right? All right, that makes sense. Any questions? No? Okay, cool. So again, you save it, and then it will appear in your component. Oh, so well, this is everything you use in a schematic. So like everything here is components. No, so these components are the entities you place in the schematic. So like everything, so this is a component. What I'm placing is a component, and that goes in schematics. Yeah. Well, the main benefit of having a component is that the footprint and the symbol are linked together, so you can't mess it up. Unlike in like KiCad or something where they're separate. What's up? No, not that I know of. They don't teach ECAD in they don't teach many ECAD tools in uni. Um, free. Nah, nah. This is Altium. This you gotta pay for this, man. No, it's not. Nah, not on uni apps. But you can use your uni symbol, so you don't need to be part of this. Not symbol, email. Sorry. So you don't need to be part of this club actually. Nah, we get it for free. We get sponsored. But the I think the benefit is we get Altium 365, which is this whole system, right? If you're like doing it by yourself, I'm not don't quote me on this, but I'm not too sure if you get a workspace. But don't quote me on it. Anyway, so the next part is the footprint. So again, we've just done the symbol. The footprint is what goes on your physical PCB layout. So again, typically you've got symbols at the start, right? Symbols at the top, and footprints are at the very last page, the very last section in the mechanical drawing section. So this is what the chip actually looks like. So the good news is you've got wizards that let you make symbols, or not symbols, sorry, make footprints from a bunch of dimensions. So you can see you've got all of these different symbol, all of these different footprint wizards. Yeah, I'm just going to go through them. But for our case, what we got here is a SOIC. Now, sometimes each manufacturer, they call them different things like, what is it? Like, this one's called PQFP, but most manufacturers call them QFPs. They don't care about the plastic or whatever material it's made out of. So they just call them QFPs. So you can so just be careful with that. Just use whatever is the closest. But in my case, it matches with SOIC, so obviously I'm just going to do that. So go to next, and then you click this button. You always click this button that generates the 3D model. Otherwise, it looks terrible, right? Like it just looks like PS2 graphics. So just click this thing, this checkbox, and you get this nice step model. Yeah. So the next step is to just put in all your dimensions. So this is annoying, but I mean you've got to do it, right? So well, this thing just calculates everything for you. Like so, if I want like a footprint with 16 pins, it just updates it for you. Well, in this case, it looks terrible because I didn't update the width, but yeah, you get the point, right? It's a wizard that just makes the footprint for you, so you don't need to like manually move stuff around. So okay, I'm gonna just put in the parameters. So the width range, you just place them in your schematics. Um, yeah, that's the whole point of this exercise. So this H is across the whole lead. So again, look to the mechanical drawing, and you can see they've got two numbers here. So this is just the upper and lower tolerance. So 6.2 and 5.8. In most of cases, you'll see that these parameters are already put in from the last person who used it. Well, not the last person who used it. I think it's the last symbol you've made with the wizard. So in my case, I've already made something similar. So I all I need to do is verify that this will match. So next one is max height. Okay, this one's different. So this one's 1.7. So I'm just going to update that to 1.7. Minimum standoff height, that's 0 in this case. So I'm going to update that. Body width range, 3.8 to 4. Yeah, so all these dimensions get generated literally into this footprint, which is on your PCB. So, mm, yeah, so this is literally what creates the pads that you see on your PCB. So if you put the wrong spacing, you like try and put your component down, but your pins are going to be too close, like physically too close on your real PCB, so you won't be able to solder it. So, oh, the height. Yeah, yeah, that's a good question, right? So why does the height matter? So in 99% of cases, it actually won't matter. Like it will just be a visual thing. But some PCBs, you've actually got like multi-layer ones. Like and Altium will actually check the height clearance to make sure that it actually fits. So actually, after this, I'll just show you an example. Um, I can show you it right now. Oh, it's like nocturnal vision or something. Yeah. So this PCB is like
Yo, wait, so you have two, no. Oh, I see, like when you have PCB stacked on top of each
mm,
other.
yeah, yeah. So Altium, actually, in my case, or not my case, sorry. In this case, like we don't have Altium Professional, which allows you to do multi-board PCBs. So this, when I made this in Altium, and I'm talking about what's this? CyberSat 2077 to those who are listening to the recording. This is actually just a component, another component, and then underneath it are even more components. And Altium actually does the clearance verification. So it's good to have the correct height. But obviously, like you know what I just did there is like 1.7 versus 1.75, like that sort of thing normally doesn't matter, and you get away with the small clearance, right? Anyway, I'll just continue and wrap this up. So you've got the body width range. Yep, the body length range, number of pins, the lead width range. Where is that? B.
Wait, so you can make an entire PCB a component?
Technically, yeah, yeah, but you won't be able to modify it, right? But I'll actually show you after this, like an example of it. Where is it? All right, so this one, so 0.51, 0.31. Again, you can change it, but if it's like 1.1 or not point 0.1, 0.01 off or something, you could honestly just leave it as is, but I do change it. Um, yep, that's good. Ah, and this is actually a good part to use because remember, we've got that thermal pad to take care of, right? So if you want a thermal pad, you click add thermal pad, and you can see, oh, you can't see it right now because I put 0 in everything, but let's just put in the right parameters. So E2, so you've got 2, 2.6, and then 2.5 to 3.1. And again, these are all in millimeters. Actually, just going to go off on a tangent. There's actually a pretty useful feature where if you put the units in, like if you do 1 IN, oh, maybe it doesn't work. I swear it did. Maybe it doesn't work. Maybe I'm lying. Oh, it doesn't work with inches. I think If you put mils, it does work, yeah, but not inches. So sometimes they have it in imperial units, but in most cases they will give you like imperial and metric. And Altium uses metric for the wizards. So yeah, add your thermal pad, and in the next steps you can honestly just click through them. You can set the density, which is like how much tolerance they give you. So low density could be useful if you're manually soldering. High density is good if you're getting everything automatically placed and you want to save space. But in most cases, medium density is just fine. And then you just click through everything. You can honestly just click finish. And then once you've finished it, it'll put you into the footprint editor wizard. Okay, so there's your footprint with all correct dimensions and everything, and you can just pan around and see how great your footprint that you just made is. And one thing I do when I use thermal pads is I get rid of the vias because the vias sometimes they might not work well because basically solder paste could get sucked through the vias to the other side and you get a half good joint. So that's that. There's your component, and then you just close it and then save it. All right. Oh, I did forget to do this. Again, make sure you've got the JLC PN if you're using JLC PCB parts. So JLC underscore PN, and then I copy this thing. There you go. And then just close it and save to server. Check save to server, and then just press save. Write your commit message if you want. I don't really care. Give it a second. Okay, and then now that you're in your schematic, you can just use that component. You can use that component wherever you want. So there you go. You can see the schematic looks good, and it would look good in the thing, but I don't want to mess up my PCB right now. And here's the example of the what's it called? The height clearance thing, right? So this is the Raspberry Pi, like all as a big symbol. Like it's just um one huge 3D model, and it's like half transparent and whatnot. I think it's yeah. So oops.
So in the premium version, you can edit it.
Well, this is a symbol, so you can't edit it. But in the premium version, you can like stack PCBs that you've made on top of each other. But you can see here the height clearance, like Altium is verifying that. See those inductors, those big circular things. It's actually verifying that um, they're not colliding. So if I do something like if I move these toll headers underneath it, then you can see it detects a collision. So the height parameter does actually have a useful value in verifying that you won't have like collision errors in your final product. But yeah, any other questions? No. Yeah, I think that's it. Um, I guess the other thing is like when you get to advanced components, you'll be making components that have like 3D models that aren't able to be generated by that wizard, right? I can see this E32 radio module. This is like a custom SolidWorks file that I made, and you can just put in like your own 3D models, step files, or SolidWorks files into your component and use that if you want, if they don't have a wizard for it, basically. And of course, you can move the paths around and everything in the wizard. So you can do complex stuff that, or not in the wizard, sorry, in the footprint editor. So you can do that sort of complex stuff. Yeah, I think that's about it. Any questions? No? Yeah. All right. Yeah, like and subscribe.